Welcome to my channel. I'm Zhan Xu. Let's talk about the problem 18 in chapter 3. In this one, we need to distinguish the average velocity and instantaneous velocity when we get the position function of time. So tell us the first one, ask us the average velocity and the instantaneous velocity for this function in this time period t equal to 1 second and 3 seconds and instantaneous velocity at 2 seconds. For these problems, when we consider the average velocity, what do we consider? We need to consider the displacement divided by time taken, right? And the time taken is easy because from 1 second to 3 seconds, just 2 seconds. Now the next one is we need to find the displacement. The displacement is the final position minus initial position. So this one is easy. Just a change of the position divided by change of time. Agree? Yes. And then when we consider instantaneous velocity, there we consider instantaneous velocity. We just consider, we take this time taken is small and small tends to 0. So this is a derivation dv dr dt. Agree? dr dt. Because at 0, the time taken we consider is super small tends to 0. This equation tends to the derivation. And then let's see how we do that. First of all, when we consider the average velocity, we consider the displacement. So the final position minus initial position. This is displacement divided by time taken. And then we input the number inside. So input the t equal to 3, it equals this one. And input the t equal to 1, it looks like this one. And divide by time t, then we get it. And there we can see the velocity still in two components, I component and k component. The next one, when we consider the instantaneous velocity, we take the derivation. And the derivation, we can see still in two directions, right? 1 and 2. So I and k. So we can see the I, there is just 9.6 times t. So we keep constant 9.6. And then this one is a constant, we drop it, and then look at the k component, 1 times 2 times t, so it looks like this one. Then we input the time inside, we can find the velocity in the two components, I and k. And then we can get the magnitude of this vector. So the I component plus j component squared. So in this one, we can say we can combine the velocity, average velocity problems with the vector problems. And there, the vector problems, we just consider these motions at 3 components, and we solve the component one by one. Okay, you can see when we do calculation for this vector, rt2 subtract rt1, we just consider this position at 3 components and do calculation as we did in vectors. Thank you.